Well, hey guys, this is a strange video for the math class, my seventh grade math class. This is November the 15th, and I did not get the video fixed right, so it didn't record this morning in the math class. It's really a shame because I had a lot of good student interaction. You would have enjoyed watching that more than just watching me. But I thought for the benefit of those of you who need this video to help you get ready for the test, I needed to at least try to work the same problems I worked in class today. I want to do this pretty quickly. Of course, the test will not be next time. It'll be right after we get back from Thanksgiving on Tuesday the 29th. Be ready. Study your notes, the handout I gave you. Make sure you know how to do those problems. That's what I'm going to be doing here in just a minute. But listen, take it seriously. Work as hard as you can. And you're going to have to watch the video like this. When I put a problem up there, when I look at a problem, you're going to have to hit pause. I'm not going to give you time to work it. I'm going to work it pretty quickly. So you hit pause, and then you can follow along with me after you've tried to work it. And if you can figure it out, fine. If not, I'll show you how. Just keep watching and you'll get it. But you're going to have to go over and over this stuff, memorize the stuff you need to memorize. Take it seriously. Don't just blow it off. You can't afford to bomb this, okay? So take me seriously. First thing we did today is talk about adding decimals. And the main thing you have to remember when you're adding decimals is number one, make sure the decimals all line up vertically. And then look at the number that has the most decimal places. In this case, it's 2, and put zeros for the other numbers. 0 here, zeros here, and then just add them like you're adding any other number. Make sure you keep the decimals lined up. When you're adding or subtracting, keep those decimals lined up. That's not true with multiplication. We'll get there in a minute. When you're multiplying, I'm going to work some example problems for you in a little while too. When you're multiplying, you don't have to line them up. So the example they give you here is 0.3 multiplied by zero point 0.7. This is a multiplication problem. When you multiply, they are lined up this time. They don't have to be. I'll show you some more examples in a minute. But you just ignore the decimals at first and just act like you're multiplying regular numbers, integers, whole numbers. 7 times 3 is 21. Then you count the number of decimal places in each of these factors. One decimal place here, another one here. That's 2. 1 and 1 is 2. So I got to have 2 decimal places here, which means I'm going to put the decimal right there. It gives me 2 decimal places. You see? I suggest you put a 0 there just so the decimal doesn't get lost in the shuffle somewhere. It's always good to put a 0 before the decimal. When you divide, later on, we'll be dividing decimals by decimals. Right now, you're dividing decimal numbers by whole numbers. And when you do that, it's pretty straightforward. Here's an example right here. 14.4 divided by 6. First of all, don't get them backwards now. It's important. You have to have the right one as the divisor. The divisor is 6. It's 6 divided into 14.4. You see that? Don't do it the other way around. If you do this, you're going to mess up. It's wrong. You're going to get the wrong answer. It's not 14.4 divided into 6. It's 14.4 divided by 6. 6 is divided into the 14.4. When you have a decimal in the dividend over here, all you do is put it up here, right above it, immediately above it, just straight up. Do that first. Then divide it like any other number. You can ignore it now. Just keep your column straight. 6 won't go into 1, but it will go into 14 2 times. 2 times 6 is 12. Subtract, bring down. 6 goes into 24 4 times. 4 times 6 is 24. And there's your answer. 2.4, 2 4/10. So let's see if there's anything back here I need to. Yeah, let's just do 2 or 3 of these examples just to give you an illustration. Again, try to do this on your own. Pause the video, make sure you can do this one. If you can't do it, follow me. So I got 1.2. This is addition. You see that, don't you? 1.2 plus 3.45. Notice I'm lining up the decimals here vertically. Plus 23.6. See how these decimals line up? All the way down, vertical. Line up. This number has 2 decimal places. So these need to have 2 decimal places. It's going to be really important when you subtract, but I would suggest you do it when adding 2. 5 and 0 is 5. Just add it like a regular number now. 6 and 4 is 10 and 2 is 12. Carry the 1. 3 and 3 is 6, 7, 8. Nothing to carry. There's the answer. Pretty straightforward. Let's do this one over here. 4.5, 0.51, 6. There's no decimal there in that 6, but it's understood that there's a decimal right after it. It's in the ones, the units place here on the, just to the left of the decimal. So you can put a decimal right there. And 12.4. The most decimal places I have in any of the numbers is 2, so I want to make sure I've got two places in all these. So helps you keep your columns straight. 1, 10 and 4 is 14. Should carry this, put this decimal down there. But remember, keep them all straight. Carry the 1. 10, 12, 13. Carry the 1. 23.41. Pretty straightforward, huh? Shouldn't have any trouble adding. If you have trouble with a problem, come and ask me about it. I'll be glad to help you with it. Let's do a subtraction problem. Still, it's just like adding. You gotta make sure the decimals are lined up all the way. Okay. Now you're ready to subtract. Not quite, are we? I need 3 decimal places. This number has 3 decimal places. I need 3 decimal places here. I gotta add those zeros. Now, when you subtract, you're going to borrow. Well, there's not anything to borrow here. So you borrow 1 over here, makes it a 6, makes it a 10. Then you're going to borrow 1 from that 10, so it makes it a 9. So it's instead of 700, you can think of it as 690, 10. 690, 10. 10 minus 6 is 4. 9 minus 3 is 6. 6 minus 9, oops, I'm going to have to borrow again. Make that a 5. 16 minus 9 is 7. 5 minus 1 is 4, and there's a 1. If on the test you want to make sure you've done it correctly, you could add this and this and see if you get that. It's a good way to check yourself. So let's do 2 or 3 more of these before we stop, before we move on to the test review. 4.2 times 0.24. Remember, you do not have to line these decimals up when you're multiplying. You're going to handle the decimals at the end. 0.24. See, those decimals are not lined up, but I'm multiplying. It doesn't matter. And at first, you just ignore them. Just multiply those 2 numbers. 2 times 4 is 8. 4 times 4 is 16. 2 times 2 is 4. 2 times 4 is 8. 8. 6 and 4 is 10. 8, 9, 10. How many decimal places? 1, 2, 3. See, the factors have a total of 3 decimal places. 1, 2, 3. So I got to move this over 3 decimal places. And it's 1. Looks like a decimal there, but it's not. It's a 2 decimals right here. 1.008. 1 in 8 thousandths. Let's do another division problem here. Let's do this n over here. 8 is the divisor. This is 48 thousandths divided by 8. 8's the divisor. Put your decimal right there. First thing, right above the decimal and the dividend. 8 won't go into 0. 0 won't go into 4. But I got to start putting zeros here because I got a decimal right there, you see. 0, 0 again. 8 will go into 48 6 times. 6 times 8 is 48. And that's the end of that problem. 0.006. 6 thousandths. Okay. I think there's enough sample problems of these decimal problems. So you know when you see these T7s, that means there's going to be a problem just like that on the test. And that will show, those problems will show up on your review handout that I gave you. All right, let me change over to the test review PowerPoint. And because Preston really wanted to see the Comic Sans font, I changed that to Comic Sans. He likes Comic Sans. All right, write 300s as a fraction. 300s, 300s. Write 300s as a decimal. If you put the 3 next, that would not be 300s. That would be 3/10. That's the tenths place. It's 300s. You got to have it in the second decimal place. That's the decimal. 300s. These both read the same way. 300s, 300s. Name the shaded part of the circle. Well, you got to know how many parts there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 of them are shaded, so it's 3/10. Both as a fraction, that's what we just did. As a decimal, 3/10. This time the 3 does come right after the decimal. That's the tenths place. Okay? We're doing problems now that are problems like the problems that will be on the test. There'll be different problems, but it's the same kind of stuff. So make sure you understand this stuff. Make sure you can do these. It's not enough just to watch me and say, oh, I understand, I see what you're doing. You got to be able to do it yourself, remember? Norton read 4 books during his vacation. The first book had 326 pages. The second had 288 pages. The third had 349 pages. The fourth had 401 pages. The 4 books he read had an average, that's the key word, how many pages per book. You know how to do averages, right? Add these numbers up. Divide by the total number of numbers. That's 4, 4 books. So it's just pretty straightforward. 326, you just have to be careful with the arithmetic you learned a long time ago. 288, 349, and 401. Add them up. Doesn't matter which order you add them, whichever is easier. 9 and 1 is 10, 18, 24. 8 and 2 is 10, 14, 16. 4 and 3 is 7, and 3 is 10, 12, 13. 1,364. That's not the answer. That's not the average. That's the total number of pages he read. We're not looking. They didn't ask for the total number. They said, what's the average? So you got to divide that 1,364 by 4. That's how many books he read. 1, 2, 3, 4. 4 goes to 13 3 times. 3 times 4 is 12. Subtract, bring down. 4 goes to 16 4 times. 4 times 4 is 16. Subtract, bring down. Don't get fooled there. There's a 0 when you subtract, but there's another 4 I've got to bring down. So you're not done just because you didn't have a remainder here. 4 goes into 4 one time. 1 times 4 is 4. And now we're done. The average is 341. It's a good idea after you've done a problem like this to say, does that kind of make sense? In other words, if you'd gotten 441, you'd look at this and say, whoa, it can't be 441. The most he read in any one book was 401. So I got to make a mistake here somewhere. See if it makes sense. Always ask yourself that question. The settlement of Jamestown began in 1607. This is how many years after Columbus reached the Americas in 1492. You know how to do it? Yeah, you just subtract 1607. Didn't write that down right, did I? 1607 minus 1492. 7 minus 2 is 5. I got to borrow here. 10 minus 9 is 1. 5 minus 4 is 1. 115 years. That's kind of an interesting little historical fact tidbit, isn't it? Jamestown was founded 115 years after Columbus discovered America. Change the percent to reduce fraction. Kelly correctly answered 80%. Percent means per 100. You might notice 10 goes into both of those. That gives you 8/10. And then you might notice 2 goes into both of those. It gives you 4/5. It said reduced, so you got to reduce it all the way down to 4/5. Be careful when you read a problem like this now. It says he correctly answered 80%, which is 4/5 of the 20 questions. How many questions did Kelly answer correctly? Read the problem correctly. Because they could have said correctly here and incorrectly here. They are going to say incorrectly on the B part. But first they want to know how many got correct. So it's 4/5 of 20. That means 4/5 times 20. I'm going to write it as a fraction, 20 over 1. 5 goes into 24 times, and 4 times 4 is 16. He got 16 questions correct. So how many did he answer incorrectly? It's easy, isn't it now? 20 minus 16 is 4. If you wanted to, you could say 1/5 is what's left over. 1/5 of 20 is 4. But the easiest way is just to subtract it. Another thing you have to pay attention to on problems like this, sometimes it will say how many, like this one, how many. Sometimes they might say what fraction or what percent or something like that. You got to pay attention to what they're asking you for. Name the shaded part of the square. Fraction, decimal, and percent. The fact that they're asking you about decimals and percents probably would make you guess that there are about 100 squares there. It should be exactly 100. But here's the way to tell quickly. Count them across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 horizontally. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertically. And 10 times 10 is 100, right? The area would be 10 times 10, which is 100 little squares. All right, how many are shaded? 1, 2, 3, 4, 5, 6, 7. 7 out of 100 were shaded. That's the fraction. As a decimal, 7 hundredths. You know how to write that now. Don't put it here. That would be 7 tenths. 7 hundredths. As a percent, 7 hundredths means 7% per 100. 7 divided by 100. 7 per 100% means divided by 100. Okay. There was a question like this on the last test that I threw out because I didn't give you a review question to cover it, and I decided it wasn't quite right to test you over it, but I won't throw it out if there's one on this test. You need to be able to plot these points and figure out this question. It says the vertices of a square, that's important, are located at, and it gives you 4 different points that you can plot on the Cartesian coordinate plane. Then they ask you the perimeter and the area of the square. Now you need to remember how to plot these points. This is the x-axis, this is the y-axis, and all the numbers are either 3 or -3. So I'm just going to make 4 tick marks here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It's going to be kind of rough, but it doesn't matter. You know, we can figure this thing out. It doesn't have to be precise. The first one is always x. Second one's always y. Alphabetical. First one's always x. If it's positive, if x is positive, you're going to the right. If x is negative, you're going to the left. If y is positive, you're going up. If y is negative, you're going down. So this point is 3, 3. That means 3 to the right and then 3 up. 1, 2, 3. 1, 2, 3. There's my point right there. That's 3, 3. 3 to the right, 3 down. 1, 2, 3. 1, 2, 3. That's 3, -3. 3 to the left and 3 down. 1, 2, 3. 1, 2, 3. That's -3, -3. One more. 3 to the left and 3 up. 1, 2, 3. 1, 2, 3. -3, 3. And it makes a square, just like they said it would. I'll change the color here. So there's my square. You say, well, it doesn't look like exactly like a square. It doesn't matter. Just get close. Now you got to decide what the length of each side of that square is. Of course, if it's a square, you know they're all the same, right? That's what it means to be a square. All 4 sides are the same. So what is that length? Well, it goes from -3 up to +3 on the y-axis. -3 up to +3. That's 6 units. -3 to +3, 6 units. -3 to +3, 6 units. -3 to +3, 6 units. It's obviously going to be 6 all the way around. What's the perimeter? You got to know the difference in perimeter and area. Now, don't make a careless mistake there. Perimeter is the distance around. And there are 4 of these 6s. The perimeter is 24. 6 plus 6 plus 6 plus 6, or 4 times 6. The area is the length times the width. 6 times 6, which is 36. Don't get area and perimeter mixed up. Let's solve this equation. You know what you do first here? Go multiply that 6 times 12. I've got 9n equals 6 times 12. You know what that is? You need to know your multiplication tables, guys. If you haven't done it, memorize those multiplication tables. I've been preaching this all year long. Your brain can memorize a lot of stuff if you'll just make yourself do it. Don't be lazy about it. Get it done. Memorize your multiplication table. 6 times 12 is 72. To solve this, this means 9 times n, and to undo that multiplication, you divide by 9, and you get n equals 8. Again, you need to know your multiplication table, so you're going to have some grief here. 72 divided by 9 is 8. 8 times 9 is 72. That's the end of that problem. What are you going to do first here? Well, you're going to go to the parentheses. And the easiest way to multiply those is to cancel. This 3 cancels with this 3. This 4 and 2 cancel because 2 goes into both of those. These are 2 down here. And you got 1 times 1 and 2 times 1. That's 1/2. So this whole thing turns out to be 1/2. So you got 1/2 minus 1/2. That's 0. You didn't have to cancel now, and this is fairly easy. So you could have said 3 times 2 is 6, and 4 times 3 is 12. And then you might notice that you could reduce that to 1/2. But if you didn't, you'd have 1/2 over here minus 6/12. Then you'd know you had to have a common denominator, which would be 12. So you got 6/12 minus 6/12, and you still get 0. In class, somebody said, I forgot what they said, it looked like an eye maybe. So we could do this, you know, if you want to, if you feel that's cool. Anyway, just don't miss a problem like this. And I stopped right there. I said, we'll cover the rest of them next time. So if you're interested in the devotion we did at the beginning of class, you can go to today's date, November 15th, any of my other classes, and you can watch the same. We do the same devotion in every class. Okay? I want to pray for you right now over the video, and you pray with me, and this will be the end of this one. Father, thank you so much for the kids watching this video. I pray you will bless them for their efforts. Help them to remember that they can't learn this just by watching me do the problems. They've got to learn how to do the problems themselves. So please give them the discipline they need to memorize these things and learn these steps and learn these procedures, and these tactics, and learn how to solve these problems. So bless them really good. Help them to do well on the test. Help them to have a great Thanksgiving break, and to be safe and to be wise and to make good decisions, and help us all to bring you a lot of glory. We pray in Jesus' name. Amen.